we have this. Okay, so this is 3.9, and hello, and this is going to be the last section from chapter 3. So this is the test is going to cover chapters 2 and 3. This is the last section from chapter 3. Okay. So 3.9 talks about derivatives of exponential and logarithmic functions. So we're going to talk about the derivative of exponential functions, log functions, and one of the big things we're going to do in 3.9 is we're going to use something called logarithmic differentiation to find derivatives, okay? Okay, so let me go ahead and scroll up just a little bit so we can talk about the derivatives of log functions. So one thing that y'all probably had some experience with, at least in college algebra, is dealing with logarithms. So when we're dealing with the natural logarithm, y equals ln of x, and we're taking the derivative and we're trying to find y prime is always going to be 1 over x if my function is the natural log of x, okay? So again, all this is saying is that if y is equal to the ln of x, then y prime, y'all, will just be 1 over x, okay? And then the second part here says if we're looking at a function called h of x, which is the natural log of some function g of x, right? So instead of just having the natural log of x, we might have the natural log of x squared plus 5, or the natural log of the sine of x, something in there, right? It'll be a natural log of something. It won't just be an x, it'll be an expression. Then the way we're going to do it is we're going to take 1 over whatever that inside function is, and then we're using the chain rule to take the derivative of whatever the inside function happens to be, okay? So again, if I have something like y equals the natural log of g of x, all we're saying is that y prime is going to be 1 over g of x times whatever the derivative of g of x happens to be, okay? Again, using the idea of the chain rule, okay? So here's our first problem. We're going to look for the derivative of the natural log of x to the third plus 3x minus 4, okay? So first thing we're going to do, we're going to find our f prime of x. So the way we're going to do this, it's going to be 1 over whatever this business here is. And in this case, it's x to the third plus 3x minus 4 times the derivative of what we have inside. So we're going to take the derivative of the inside part now. And so we already know the derivative of x to the third, everyone agree, is a 3x squared. And then what's the derivative of 3x? 3. Okay, and so my final answer, y'all, I'll probably just write it like this: 3x squared plus 3 all over x to the third plus 3x minus 4, right? So I'm just writing that top part, the derivative of the top, over the original function itself. Okay. And so again, we were able to find our derivative, okay? So let me continue going on here. And what we're going to talk about next, y'all, is something called logarithmic differentiation. So if we're taking the derivative of a function using logarithmic differentiation, a couple things we're going to do. We're going to take the natural logarithm on both sides of the equation, okay? Once we do that, we're going to use certain properties of logarithms to expand the natural log of usually the right side as much as we can, okay? So y'all, one of the things that I did, I took these notes directly from my college algebra class because again, the last time you probably saw logarithms might have been like in an algebra course. Again, I taught pre-cal last semester. I don't even think we touched on logarithms at all. So the last time you would have seen it, again, if you had college algebra here or at another school, might have been, a couple of semesters ago. So I put some of these properties up here so that we can use them. And then when we take the derivative on both sides of the equation, on the left side, we're always going to have 1 over y and then dy dx, okay? We're going to multiply both sides of the equation by y to solve for dy dx, and then we'll replace y with whatever that function happens to be. So let me go through this so that we kind of have an understanding of what it is I'm doing. Guys, before I go on, just looking at some of these properties of logarithms, I want y'all to kind of keep in mind what logarithms are, right? So logarithms, again, if you, and this is for like general logarithms, but I'm going to write down the definition of a logarithm just so that we remember what logarithms are, okay? Because again, I know it's been a long time since we've probably seen logarithms, but logarithms are, in essence, they're exponents, right? And so this is the definition of a logarithm right here. It says y equals the log base a of x. Is this little double arrow is equivalent. And in English, it's like it means the same thing as, okay? It means the same thing as a raised to this power y will give me whatever my value of x is, okay? So I want you to think about what we have here. We have exponents, right? So think about certain properties of exponents. Like say I were to ask you, say what's x squared times x to the third? You already know what the answer is, right? It's x to what power? It's x to the, guess again, fifth, right? It's x to the fifth, right? Why? Because when we're multiplying, what do we do with our exponents? We add them, right? I want you to notice something here. See how that x and y are being multiplied? What are we doing with them right there? Oh, we're adding them, right? If you think about something like, say, x to the seventh over x squared, would y'all agree with me that that's x to the power 5? Because when you're dividing exponents, you subtract them, right? So again, I want you to think about something here. Look, when I'm dividing my log expressions, I'm subtracting them, right? Because that's what, in essence, I do with my exponents, right? So again, I just kind of want to go over some, kind of remind you of some of those rules, because that's what I'm basically going to be using to do these problems here, okay? So let's see if we can start off with the first problem. Let's see if we can start off with the first problem. We're going to go super, super slow. Okay, the first thing I'm going to do, y'all, instead of me using f of x, I'm going to write it as y equals x to the 8th times x minus 5 to the 5th all over x squared plus 4 squared, okay? All right, so that's usually my first step, y'all. I'm just going to write it with a y, okay? My next step is, John, do you mind doing me a favor, John, closing the door because I heard some noise out there? Thank you, I appreciate it. My next step, y'all, is when I'm doing this problem, we're gonna start following the logarithmic rules, okay? So I'm just gonna kind of scroll back up here so we can see that again. So I want you to notice what it says we're gonna do. We're gonna take the natural logarithm on both sides of the equation, okay? So I'm just gonna kind of go through my 1, 2, 3, 4, 5 here. So let me come back here. Okay, we're gonna take the natural log on both sides. So I'm gonna have the natural log of y equals the natural log of all of that x to the 8th, x minus 5 to the 5th, all over x squared plus 4 all squared. Okay. So step number 1 says we're taking the natural log on both sides. Okay, so that was my step 1. Step 2, okay. Let me come back over here, y'all. I'm going to scroll back down to my steps over here. Number 2 says we're going to use these properties of logs. So these properties right here, you guys, we're going to use those properties of logarithms to expand the natural log. This is really on the right-hand side. Okay, on the right-hand side as much as we can. Okay, so look, let's do this. Let me kind of zoom out again just so I can see a little bit better. So on the left, I'm going to leave the natural log of y. But on the right, I want to expand this guy right here, okay? So everybody agree that these two here are really being multiplied inside, that x to the 8th and the x minus 5 to the 5th are being multiplied? So look at this first property of logarithm. It says, look, if I'm multiplying them, I can actually write this as two different logs being added. So I'm going to write this as the natural log of x to the 8th plus the natural log of x minus 5 to the 5th, okay? And I want to show you one other part. Since this guy here is being divided, look what we do when we divide. Whatever is on the top stays there, and then we have a minus with whatever was on the bottom. So now I'm going to put a minus natural log of x squared plus 4 all squared. L and y. Okay. Now, y'all, there's a third property of logarithms. Okay. The third property of logarithms is the power property. Okay. So I'm going to write it just so it's a little bit bigger so I don't have to keep zooming out and zooming in and all that kind of stuff. So it says the log base A of x to the power r is the same thing as r times the log base A of x. So this is telling me that if I have a power I can bring that power down to the front and it's going to get multiplied by those logarithms. So I don't know about you guys, but I see a whole bunch of powers here, right? Okay, so look, we're going to continue here. We're going to natural log of y. This 8 is going to come down to the front, natural log of x, okay? Plus, this 5 is going to come down to the front, natural log of x minus 5, okay? Minus this 2 here is going to come down, natural log of x squared plus 4, okay? Now, y'all, I want to emphasize something here. The reason why we were able to break up into those three pieces is because we essentially had three factors, 2 being multiplied on the top, 1 being divided on the bottom. I can't break up the individual pieces though. So I have to think of that x minus 5 as one value. And I have to think of x squared plus 4 as one value. I can't break up the inside, but I can break up those types of pieces, okay? All right, so we got step number 2 done. So look, I'm going to scroll back up so I can take a look at what my step number 3 tells me what to do. Step number 3 says we're going to take the derivative on both sides of the equation, and this is what it's going to look like on the left, okay? So my step number 3, we're going to take the derivative on both sides. We already said that the derivative of the natural log of y would be 1 over y with a dy and dx. Okay. All right, now we're going to do these next 3 pieces, y'all, individually. Okay. So 8 is going to stay there. Now, the natural log of x, we talked about this at the very, very beginning. The derivative of the ln of x is going to be 1 over x. Okay. Plus 5 times the derivative of the natural log of x minus 5, 1 over x minus 5 times the derivative of what I have inside. What's the derivative of x minus 5 anyway? Right? So if you want to put a times 1, that's fine, right? It's not really changing it, but I'm putting it there because I want us to make sure that we understand, hey, you still got to really take the derivative of what's inside, right? Okay, minus 2 times 1 over x squared plus 4 times the derivative of what's inside. What's the derivative of inside? 2x? Right? Okay. So far, are we good on how we got to where we are? Okay. So, next thing I'm going to do, y'all, I'm going to do a little bit of simplifying here. 1 over y dy dx equals. Y'all agree I can write that as an 8x and a 5 over x minus 5 and a minus 4x over x squared plus 4? So far, we doing okay? Okay, just checking with you guys. Okay, so y'all, when I went through, like I said, I told you guys before I do the lectures, I always go through the problems myself, and I'm checking my answers, making sure, you know, that we're all coming up with the same thing. So one of the things I noticed about these problems here, for this section, y'all, 3.9, they're kind of a stickler on how they want you to write it, okay? So this is what we're going to do next. We are going to get all of these folks together. And if we're going to get all of those folks together, that means we are going to have to get a common denominator, right? And between x minus 5, and x squared plus 4, all 3 are going to be my common denominator, right? Because they're all 3 different values, you know what I mean? So think about it this way. If I were to ask you, what is 1/2 plus 1/3 plus, say, 1/7, you'd say, oh, my common denominator is going to be 2 times 3 is 6. My common denominator is going to be 42, right? You'd have to multiply all of them together. Why? Because they're all different, right? So same thing over here. They're all different. X is different from x minus 5. It's different from x squared plus 4. Okay, so look, this is what we're going to do. We're going to do a little bit of algebra. So I still have a 1 over y and a dy dx on my left side. Now, on my right side, y'all, I'm going to write three new fractions, with my denominators being x, x minus 5, and x squared plus 4. Let me give myself a little bit more room because I'm going to need it. Okay, so my denominators were x, x minus 5, and x squared plus 4, x, x minus 5, and x squared plus 4, x, x minus 5, and x squared plus 4. Okay, so this is going to be the name of the game. Look at what we already had on the top over here. We already had an 8. I don't want to forget it. It's part of my answer. Okay. Now, next question. What did I put down here that I didn't have before? There you go. X minus 5 and x squared plus 4. Okay. On the second part, we already had a 5. What did I put down here that I didn't have the first time? Very good. X and x squared plus 4. Okay. Over here, y'all, we already had a 4x. What did we put down here that we didn't have on this one? And the x? That x also? Okay, so we need another x and an x minus 5. Before I go on, are we okay in how we got to where we're at? We're just really adding fractions at this point, right? Okay, so look, y'all. This is what our denominator is going to look like. Okay. Now, we're going to do some multiplying now. Okay, so I'll tell you what, we'll leave the 8 alone for right now, but let's go ahead and multiply this guy out. So x times x squared, everybody agree that's an x to the third? X times 4, that's a 4x. Negative 5 times x squared is a minus 5x squared. And negative 5 times a positive 4 looks like to be a minus 20. Okay. All right, we're going to do the same thing over here. Let's multiply this 5x times both those pieces. So 5x times x squared. Everybody agree that's a 5x to the third? And 5x times 4, that looks like a 20x. Okay. Yo, quick question. Right here where I have the 4x times another x, can I think of that as 4x squared? Right? 4x times another x, isn't that the same thing as 4x squared? Okay, so let's go ahead and multiply that guy out. So 4x squared times the x minus 5, everybody agree that's going to be a 4x to the third. What is that, minus 20x squared? So far we're doing okay? All right, let's keep going here. Now we're going to have 1 over y dy dx equals, let me go ahead and distribute this 8, y'all. So that's 8x to the third plus 32x minus 40x squared minus 160 plus 5x to the third plus 20x plus 4x to the third minus 20x squared. Uh, Yes, I'm sorry, John, you were right. And it was a plus 20, wasn't it? You're right. Sorry about that, y'all. So because it was a negative there, it was a negative 4 to the third, and a negative 4 and a 5 is a plus right there. Yep, that was my bad. Thank you for catching that. Minus and plus. There we go. Thank you. All over x minus 5, and x squared plus 4. All right, I got a question for you guys. Can we combine any terms upstairs? Okay. What's 8 plus 5? 13. What's 13 minus 4? 13 minus 4? 9. 9x to the third. Very good. Okay. 9x to the third. Excellent. Okay, so we got rid of that one. We got rid of that one. We got rid of that one. Okay. Let's do the same thing now. Let's take care of our x squared. Look, y'all, what about a minus 40x squared and a plus 20x squared? Minus? Yeah, negative 20x squared. Okay. Let's see. Let's take care of our x's next. What about a positive 32? And it looks like we got a positive 20. 52x. Okay. And then, let's see, is it just the minus 160 at the end? Minus 160 at the end, okay. All over x minus 5, and x plus 4. Okay. Okay, so next step, y'all, I want to show you something. We got our 1 over y dy dx equals all that funky stuff on the right side, right? Okay, I'm going to scroll back up here because we're going to take a look at step number 4. Step number 4 says we're going to multiply both sides of the equation by y to solve for dy dx. Okay? So now we're going to come back over here and we're going to say, look, let's multiply both sides of the equation by y. So do you agree that this y and that y would cancel out right there? Okay. So look, we're going to have dy dx equals 9x to the third minus 20x squared plus 52x minus 160 over x minus 5, x squared plus 4. And then I want to come back. I want to see if remember what the value of y actually was. Okay. So look, I'm going to scroll back over here, y'all. Wasn't y actually equal to this y right here? That was what our y was. That's how we started off the problem. We said y was equal to, I know the original problem said f of x. All we did is we said f of x is the same thing as y. So I'm going to replace what we have on the right side, that y, I'm going to replace it with that x to the 8th, all that kind of funky stuff. So right here, we're going to have x to the 8th, x minus 5 to the 5th, all over x squared plus 4 squared, right? So far, are we okay? Jennifer, am I doing all right? Okay. Okay, so the last step, y'all, one more simplification. Okay, question. Do you agree that this x here will cancel with one of those on the top? Because they're both x's. The one's upstairs, the one's downstairs. Okay, so look, I'm going to leave all this funkiness alone. Okay? But since this x is going to cancel with one of those, I'm going to be left with an x to the what upstairs? 7. Okay, next question. Do you agree that this x minus 5 on the will cancel with one of those x minus 5s on the top? Because on the top, there's actually an x minus 5 to the fifth. And on the bottom, there's an x minus 5. So if I cancel this one here with one of those, aren't I still left with an x minus 5, what, to the fourth? Okay. And then finally, the last step, y'all, I want you to look at the bottom part. Look what I still have on the bottom. I have an x squared plus 4, and I have another x squared plus 4 squared. So how many x squared plus 4s do we really have? There you go. And there's our derivative. So guys, one thing I noticed when I was going through these problems myself was that logarithmic differentiation is a way to find the derivative of a more complex expression or a more complex function, okay? And I want you to think about the original function that we had. If we were doing the original function, we would be taking the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. When we would simplify all of that business, this is what we would end up with, okay? And so the idea is logarithmic differentiation should be easier than if we were to go through like using the quotient rule, because if you look at the top was originally an x to the eighth and an x minus 5 to the fifth. So when I'm taking the derivative of the top, I would have to use the product rule as well, right? So not only am I using the quotient rule because I got to do the bottom times the derivative of the top, but because the top is a product, I got to use the product rule there, and I got to go through all that business, right? So the idea is logarithmic differentiation, even though it's not necessarily easy, it's easier than if we were to go through using the quotient and the product rule, okay? And y'all, we're going to go through a bunch of these problems to make sure that, you know, we get the hang of it. And I think it's going to be kind of a similar experience as what we had on Monday when we were doing implicit differentiation. The first couple of problems were a little challenging, and then as we got towards the end, they were like, yeah, we kind of had the hang of it, okay? All right, so guys, let's try the next one. Again, we're going to go real slow. We're going to do one piece at a time, okay, so that we can make sure that we understand what's happening here. Okay, so look, y'all, step number one is always going to be this. Y equals 8x minus 2 to the third times 8x squared plus 2 to the third. Okay. Step one, just write it with y. Okay. Step two, we're going to take the natural log on both sides. I'm sorry? The natural log is the logarithm with a base of e. Okay. So remember, y'all, I'm taking the ln on both sides. Okay. Step three, y'all, we're going to expand this piece. Okay. So the left isn't going to change. Still going to stay ln of y equals. Remember, using those properties of logarithms, right? Again, y'all, I put the properties of logarithms up here. So I have them in your notes, right, so that you can access them. But again, the property that I'm going to use is I'm taking the logarithm of a product, so I can write it as the sum of two different logarithms. Okay. I come back to my problem. Look, here's the logarithm of product, so I'm going to write it as the sum okay. So the log of 8x minus 2 to the third plus the log of 8x squared plus 2 to the third. Okay. I'm still on step 3, y'all. Okay. I'm still on step 3. We're going to continue to expand this thing out. So the way we expand this part out now, still using properties of logarithms, is that those exponents will move down to the front, and I don't have those powers anymore. Again, y'all, once I get to this step, in terms of me expanding my logarithms, I'm done. I can't expand it anymore. Again, just a quick reminder, y'all, I can't separate what's inside the logarithm. Like, I can't separate the 8x minus 2. I can only separate things that are being either multiplied or divided. I can't separate individual sum and differences inside my logarithm. Okay? Now, step number 4, y'all, we're going to take the derivative on both sides. Every time we take the derivative of the natural log of y, y'all, it's always going to be 1 over y dy dx. When we were here on Monday, one of the things we said is if we didn't want to use dy dx, we could use y prime, right? So whatever notation you guys want to use, that's fine. Okay, I'm putting dy dx, but if you want to put y prime, we'll probably do one where we put y prime in a minute. It's the same thing. Okay, don't get hung up on the notation so much. Okay, here's 3. The way we take the derivative of a logarithm, it's always going to be 1 over whatever I'm taking the logarithm of times the derivative of what we have inside. What is the derivative of 8x minus 2? 8. Okay. Yes, it's in the front. It's being multiplied using our properties of logarithms. Okay. So look, same thing for the next part. Look, I'm going to write 3 times 1 over 8x squared plus 2 times the derivative of what we have inside. So anybody know the derivative of 18x squared plus 2? 16x. Excellent. There you go. Okay. Y'all, this is still continuing with step number 4. Step number 4 is kind of a long step. This is when we're going to start putting stuff together. So over here, everybody agree that's really a 24 over an 8x minus 2 plus this here should really give me a 48x over an x squared plus 2. So far, so good? Okay. Second step, y'all. You got to get those two folks together, right? And in order to get those two folks together, we need a common denominator, which is going to be both of them. Okay. And I think the easier way to kind of go about this is to always put the pieces that you had already upstairs and then do what I call stare and compare. Okay. Look at what I wrote right here and look at the first fraction. What's the missing piece? There you go. 8x squared plus 2, right? And then, y'all, we're going to do exactly the same thing over here. We're going to say, look at this piece and look at the original fraction. What do I have on the bottom that I didn't have the first time? The 8x minus 2, right? Good. Okay. Okay, I'm still doing step number 4, y'all. Again, step number 4 is, this is kind of like the long step. Okay? And again, y'all, one thing I want to emphasize, we have done the calculus part of it. What we're doing now is we're doing the algebra. So really, one of the things about, I think one of the good things about this class, it's making us hone our algebra. Y'all know what the word hone means? Y'all know what a hone is? You ever go to the meat market and you see the butcher and they have the knife and they're doing this, right? So that thing that they're rubbing the knife on, that's called the hone, right? That's the skill. What are they doing? They're sharpening the knife, right? So what we're doing here, y'all, we're just honing our skills. We're getting our algebra skills a little sharper because, again, I know it's been a little while since we probably had some algebra and we had to do some of the stuff, but that's okay. We're going to work this together. Uh, yeah, I guess. Honestly, I don't. I would have to go and look through it. Okay, so let's take a look here, y'all. So 24 times 8. Oh, man, I don't know. Let me grab my calculator. Let's see. Boom, 192. Thank you. 192 x squared plus 24 times 2. Hey, I know that's 48. 48 times 8. Quien sabe? Let me grab my calculator. Where did it go? Here we go. 48. 48 times 8. 384. So that's a 384x squared minus 48 times 2 should be something like a negative 96x. All of this now, y'all, is over 8x minus 2 and 8x squared plus 2. Okay. All right. And I bet you we could at least combine the 192x squared and the 384x squared. Okay, so add it to 192, 576. Okay, so we have a 576x squared, excuse me, minus a 96x, and then a plus 48 all over 8x minus 2 and 8x squared plus 2. Okay. All right. My next step, y'all, step number 5, very good. We're going to multiply both sides by y. Oops. Yeah, remember, we start off with y. What we're doing here, John, is we're taking the logarithm on both sides, and then we're taking our derivative, right? Okay, so y'all agree this y down here is going to cancel out? So we multiply by y? Okay. So step number 5, y'all, we're going to have dy dx is equal to 576x squared minus a 96x plus a 48 all over 8x minus 2 and 8x squared plus 2. And then what did we say our y was to begin with? 8x minus 2 to the third, right? 8x minus 2 to the third and 8x squared plus 2 plus 2 to the third. Okay. So again, all I did is I took it from right here, right? From right here. There was our original y. Okay, so let me scroll back in just so I can see that a little bit better. Okay, and last part, this is where we're going to do some of the canceling, right? What's going to go away? Is anything going to cancel? Anything on the top going to cancel anything on the bottom? Y'all agree this 8x minus 2 will cancel with one of those, and I'm still going to be left with how many of them, right? And then wouldn't this guy down here cancel with one of those, and wouldn't I still be left with two of those as well? Okay, so now look what we have. We have dy dx equals all that funky stuff, 576x squared minus 96x plus 48 times 8x minus 2 squared and 8x squared plus 2 squared. Well, look, how many 8x minus 2s do I have down here? Just one of them, right? How many do I have up here? So when they cancel, we're still left with 2, right? And we're done. It's a lot of steps. There you go. Good. Very good. Okay. So look, y'all. Let's take a look at this next one here. So we're trying to find the derivative of the natural log of 7x plus 7 over 3x squared plus 3x plus 9. Okay. So let's see if we can do this. We're going to go through it one piece at a time. Okay. So I want you to do something here, y'all. We're taking the derivative of the natural log already. So we're not doing. We already have the derivative. We already have the natural log on both sides, right? So look, question. Well, I'm going to show you right now. Oh, come on, Ken. Here we go. Okay, so look, I know I'm going to take the derivative of this. Can I separate this as 7x plus 7 minus the natural log of 3x squared plus 3x plus 9? Using just properties of logarithms, right? So we can still separate it because we have the derivative of a fraction, right? Now again, we're still taking the derivative of this whole business right here, right? We're still taking the derivative of that. All we did is we said, well, before I take the derivative, let me go ahead and break it up just a tiny bit, okay? So think about it this way. This is your y. You're taking the derivative of that, right? Okay, so look, let's take a look here. If we wanted to find the derivative of the natural log of 7x plus 7, what would we have to do? Everybody agree 1 over 7x plus 7? Remember, because the derivative of the natural log is going to be 1 over whatever I'm taking the derivative of times, y'all, the derivative of this guy. So what's the derivative of 7x plus 7? Good. Minus, same thing here, 1 over 3x squared plus 3x plus 9 times the derivative of what we have, again, inside. So what's the derivative of 3x squared plus 3x plus 9? There you go. Okay. All right. Again, y'all, we're going to go ahead and write a single expression here. So everybody agree that my common denominator is going to be 7x plus 7 and 3x squared plus 3x plus 9? Okay. So remember what we already had on the top in the first part. Didn't we already have a 7 here? And over here, didn't we already have a 6x plus 3 on the second part? Okay. Question to you guys. What am I going to put next to that 7? Now, remember, look at the bottom parts. 3x squared? Good. 3x squared plus 3x plus 9? Excellent. What am I going to put next to that 6x plus 3? Perfect. Very good, y'all. Good job. Okay. So now, look, y'all, we're going to write one big fraction. 7x plus 7 and 3x squared plus 3x plus 9. And now all we're going to do is we're going to just do a little bit of multiplying upstairs. So this one should be easy for us to do because all we're doing is multiplying by 7. That's going to leave me with a 9x squared plus 9x plus 63. Oh, man. Should be easy, and I'm all messing this whole thing up. Sorry about that, guys. 21x squared. Yeah, I don't know what I was thinking. What did I write the first time? 9? Yeah. Did I have the 63 part right? Okay, yeah. Yeah, I don't know what happened there. All right, let's take a look now. Okay, minus. Now look, y'all, I'm going to keep this part in parentheses because I am subtracting it. So I'm going to have to change signs in a second. Okay, let me make sure I don't mess anything up here. So let's see. 42x squared. Good. Keep me in check, y'all. 42x. 21x. And 21. Let's see. 21x squared plus 21x plus 63 minus, yeah, if we combine these together, that would give us a 63. Okay, so why don't we do this? A plus 63x, just so that we know that's what it is. Ready? Okay, and let's distribute our minus signs. So that's a minus 42x squared, a minus 63x, and a minus 21. All over this funky stuff down here in the bottom. 7x plus 7, 3x squared plus 3x plus 9. And last step, can we combine anything upstairs? Yeah, 21 and a minus 42, isn't that a minus 21x squared? And what about a plus 21, y'all, and a minus 63? Excellent, good. Negative 42 with an x. And then finally, what about a 63 and a 21? 42? Positive, right? Okay, we're almost done, y'all. Almost done. Take a look here. 7x plus 7, 3x squared plus 3x plus 9, okay? Now, guys, I'm going to do one extra step. And the reason I'm going to do this is because I can see these numbers, and I'm probably going to say that my open math is probably going to ask you to do this as well. Well, no, I don't want to multiply the bottom, but let me ask you a question. Do you agree that we could factor out a 21 out of the top? Does 21 go in all of them? Okay, so look, let's do this. So I'm going to actually factor out a negative 21, okay? When I factor out a negative 21, y'all, all the only thing we're doing is we're changing our signs. So that's an x squared, that's a plus 2x, and that's a plus 2, or a minus 2, sorry. Okay, let me ask you a question. Can I factor a 7 out of here? Okay, let me ask you another question. Can I factor a 3 out of here? So if I'm factoring out a 7 and I'm factoring out a 3, aren't I really factoring out a 21? You see what I'm saying? So when we factored the 7 from here, didn't we get an x plus 1? And if we factored a 3 out of here, wouldn't we end up with an x squared plus x plus 3? You see what I'm saying? And then now, what's the only thing that's going to cancel? The 21. And you're done. The hardest part of these problems, y'all, is the algebra, because the calculus, you know how to take the derivative. The hardest part of this here is the algebra, okay? And it just takes time. It just takes time to go through it. Again, it's just like it's practicing it, right? And the more problems you do, the better you're going to get. Look, I made mistakes there, right? We're all going to make little mistakes. When that happens, just okay. I usually what I do, I mean, like you guys caught me, right? It's like, and I was putting like a +2, and it should have been a -2, something like that. So that happens, you know. If you can catch it, great. If not, a lot of times what I do, I just like start over. It's hard for me to find. For me personally, it's hard for me to find my mistakes when I'm going through it. A lot of times what I'll do is like tear out the paper. Okay, let me try this again. You know what I mean? But it takes time to do, right? It takes time to do. Yeah. So again, y'all, I want us to go through these problems so that, again, we have practice, plenty of practice to go through these here. And one of the things is the directions are going to tell you on how to do the problem. So again, y'all, if you notice, I'm copying these problems directly from your homework, right? And look what the directions tell me. The directions are telling me, let's use logarithmic differentiation to find the first derivative. And then it says, let's write our answer without fractional or negative exponents. Okay, so we're going to use logarithmic differentiation. So number 1 is actually already done for us, y'all. It's already in the form y equals. Okay. Remember, step number 2, we're going to take the logarithm on both sides. Okay. Natural logarithms, right? Guys, the reason why we do the natural logarithms, you can take the derivative of other logs, but then you have other factors that have to be involved. And with a natural logarithm, you don't need it. It's easier to do. Okay, step number 3, or step number 2, or actually I think it's number 3, we're going to expand this piece a little bit. Look, y'all, isn't that a power right there? So remember what happens to our powers? They drop down to the front. And so we just have sine x times the natural log of x. All right. Step number 4. Now we can start taking our derivatives. Okay, so anybody remember what the derivative of the ln of y is? 1 over y, one more part. dy dx, right? Good. Okay, y'all, we have a product here. So look, I'm going to do it like this. I'm going to think of this as the first. I'm going to think of that as the second. When I'm taking the derivative of the product, it's always the first function times the derivative of the second. What's the derivative of the ln of x? 1 over x, right? Plus the second function, which is the natural log of x, times the derivative of the first. What's the derivative of sine of x? There you go. You can, you can, you want to, or you know what we can do? Can we write it like this? Just so we know, there's a little bit of separation. If you want to put a parenthesis, you're more than welcome to. Y'all, question. In order for me to get these two folks together, we need to get a common denominator, right? What's the denominator that I have right here, even though I don't see it? 1. Okay, so between x and 1, what is it going to be? Good. Question. What did we put down here that we didn't have before? The x. So look, y'all. There's my x, right? We're basically multiplying the top and the bottom by x so that we can get a common denominator. Okie dokie. So now we have 1 over y dy dx equals sine x plus x cosine x ln of x all over x. Okay. Yes? No. Remember, when I'm taking the derivative of a product, it's the first function times the derivative of the second. And isn't the derivative of ln of x 1 over x plus the second function times the derivative of the first? And the derivative of sine is the cosine, right? Does that make sense? Good, good. Good questions, you guys. Good questions. Okay, last step. We got to multiply both sides by what? The reciprocal. We got to multiply both sides by y. So that y and that y are going to go away. We know that. And we're going to have a dy dx equals a sine x plus x cosine x natural log x over x times, what was our y to begin with? X to the power of sine x, right? Looking a little bit like pre-cal, right? Because you're seeing some more of those trig functions come into play. At that step, y'all, about all we're going to be able to do. Can't really do much more with this. Okay. Notice what the directions told me to do. It said to write my answer, let me zoom out a little bit, write my answer without fractional or negative exponents. So if you notice, none of my powers are fractions, right? So I don't have anything to the power 1/3 or 1/2 or 1/8. I don't have any exponents that are negative, so we're good. Okay. That's what I'm saying. So look at what the directions are telling me, right? Make sure that I'm writing it without negative exponents or fraction powers, and I don't have any negative exponents and I don't have any fraction powers, right? So as long as I'm following the instructions, you guys, I should be good. You know what I mean? Like that should be the end of it right there. Okay. All right, so I'm going to keep scrolling along here. We're going to do the same type of problem here. Look, and again, we're going to do it for evaluating it, right? So again, the first part, the f prime of x, that's what we've been basically doing so far. The second part is just the evaluation. Shouldn't be a big step for us, right? So let me get a little bit of water, you guys, and then we'll continue. All right. So going to the next problem here, y'all. First step I'm going to do, remember step number 1, I'm going to write it as y equals x to the power 6x, right? So my first step is always writing it with y. Step number 2, I'm going to take the natural log on both sides. Okay. Step number 3, we're going to expand this piece. What can we fix here? If we're taking it as the natural log of x to the power 6x, what can we move? the 6x, right? Everybody agrees 6x is going to come down to the front? Okay. Now, y'all, step number 4. This is the calculus part. We're going to take the derivative, on both sides of the problem, okay? So remember, the derivative of ln of y, 1 over y, dy dx. Guys, I'm going to write y prime. Remember, the notation isn't really important. As long as you understand that you're still taking the derivative of that function y, right? Okay, now, second part is we're going to take the derivative of this piece here. Remember, y'all, think of this as two functions, the first and the second, right? So when I'm taking the derivative of product, it's always the first function, which is 6x, times the derivative of the second. Well, the derivative of an ln of x is a 1 over x, plus the second function times the derivative of the first. Okay. Question. Y'all agree that those x's are going to cancel? So we have a 6. Can I write this as 6 ln of x? I'm just putting the 6 in the front, right? I don't want to think about it as the ln of 6x, right? Because it's 6 times the natural log of x. Okay. All right. Second step, y'all, or step number 5. Not second step, but step number 5. We're going to multiply everything here, y'all, by y. Okay, so I want you to look at the directions. The directions say use logarithmic differentiation to find the derivative. Hey, we did. So right here, y'all, where the f prime is, I'm just going to write 6 plus 6 ln x, all of that times x to the power 6x. There's my answer for the first part. Okay, let's call this part A. We'll call that part B. So now, y'all, if we're going to do part B, and we're going to find the derivative at 1, what does that mean we're going to do? Substitute them 1, right? Okay, let's do it. So let's see, 6 plus 6 times the natural log of 1 times 1 to the power 6 times 1. Okay. We'll go real slow here. 6 plus 6 times, I'm going to grab my calculator, y'all. I want to figure out what the natural log of 1 is. So on my calculator, here's my ln. ln of 1, 0. Okay. Okay. 1 to the power of, what's 6 times 1? 6. Okay. So 6 plus 6 times 0 is 0. What's 1 to the power 6? 1. Isn't that just going to give me 6? No. Y is not 1. We are finding the derivative at 1, right? See what it has here? What is that 1 indicating? I'm putting 1 for x of function, and I'm finding the y prime at 1. I'm finding the y value of the derivative at 1, right? So I'm plugging in x equals 1 to find y prime at 1. I'm sorry? Okay, remember what I was asking you to do here? It was just asking me to find the derivative of 1, right? It's not asking me to find the equation of the tangent line, right? So the only time I need to know the x and the y is when I'm finding the equation of the tangent line, right? Okay, what formatting are you looking for? That's what I'm asking.
Keyword the X line and to the bottom, one comma.
Okay, so 1 comma what? What was that comma? That's the y value, right? The y value at what? The y value at what though? What x value we're looking at then? So wouldn't you come back to this function here, and everywhere you have an x, plug in a 1, and you would find your y value? Oh, I don't know. I hadn't done it yet, right? Because it wasn't asking me to. You understand my point? It wasn't asking me to do that. So right here, y'all, I'm just going to put 6, because that's what we have to do, right? And you got it. So again, y'all, question: is finding the logarithm or derivatives using logarithmic differentiation, is it getting any easier as we've gone through? Like, is this one any easier to do? This problem was probably easier because it was simpler, right? It wasn't real complex like those first couple that we had. But are you all understanding, like, the first step, write it as y equals. Second step, take natural log on both sides. Break up your natural log. That's, I think, the hardest part, is just breaking up the natural log. And then if you think about the other parts, guys, I don't necessarily find it difficult. I would say it's more tedious, right? Because you're having to like to distribute and watch your signs, all that kind of stuff. But it's not like it's hard. You know what I mean? It's not difficult to do. It just takes time to do it. Good, very good. Okay, so next part, what we have here, y'all, are derivatives of the natural exponential function, right? So earlier, John's question is, what was the ln of x? The ln of x, y'all, is just the log with the base e of x, okay? So again, this is just like college algebra stuff, but natural log is the same thing as a log base e of x, okay? So when we're taking the derivative of e to the x, if my function is e to the x, the derivative is the same exact function, okay? But using the chain rule, if I have the derivative of e to some particular function, it's going to be e to that function times the derivative of whatever my exponent happens to be. Okay, again, this is using the chain rule, right? So look, take a look here. We have e to the power 4. Uh, no, I think those are x's. Yeah, they're x's. And it looks like the power, the 4 is being raised to a power, right? Give me 1 second. Hold on. Right. Okay, so we're going to take the derivative. When we take the derivative, it's going to be the same thing. It's going to be e to the power 4 of the power x squared plus 7x plus 5. Okay, and we got to take the derivative of the power. Let me see. Give me 1 quick second here, y'all. I thought I had done this one, and maybe I didn't. So if this is 4x squared plus 7x plus 5, let me try this real quick. Sorry, I should have done this earlier. Okay, so I'm kind of doing this in my head right now as I'm going through, but this is what I'm going to do. I need to take the derivative of my exponent, okay? So this is what I'm going to do, y'all. We're going to say our exponent, we're going to call that g of x, okay? We're going to say g of x is the same thing as 4 to the power x squared plus 7x plus 5, okay? We're going to use logarithmic differentiation here, you guys. So look, I'm going to write this as y equals 4 to the power x squared plus 7x plus 5, okay? Remember what we're going to do now. We're going to take the natural log on both sides. So the natural log of y equals the natural log of 4 to the power x squared plus 7x plus 5. What am I going to be able to move here on the right side, you guys? X squared plus 7x plus 5? Good. Okay. So we're going to have the natural log of y equals 4 x squared plus 7x plus 5. You'll agree times the natural log of 4? Okay. Now, we're going to take the derivative on both sides. So 1 over y prime equals. Question, or I want to point something out here. Do you guys understand that this is really a constant? It's just the natural log of 4. It would be a value, right? So if I were to take my calculator right here, and I were to do this, I could say, look, the ln of 4 is 1.386, right? So it's just a constant, okay? So we're going to take the derivative of each individual piece. The derivative of 4x squared, 8x. The derivative of 7x, 7. And I still have times the natural log of 4 because it's just a constant, right? It's just a value. Okay. All right, we're almost done finding our y prime. So now, y'all agree on both sides we got to multiply everything by y? So those are going to go away. I'm sorry, say that again. Oh, it was x squared. It wasn't 4x, it was x squared, right? That's right. You're right, my bad. X squared, so that was really a 2x, wasn't it? Thank you. Okay, so we got a 2x plus 7 times the natural log of 4, and then y happened to be this funkiness right here, right? 4 to the power x squared plus 7x plus 5. Okay. So what did we just do? We took the derivative of that exponent. So my final answer, f of x, is e to the power 4 x squared plus 7x plus 5 times 2x plus 7, natural log of 4, times 4 to the power x squared plus 7x plus 5. Let me clean this a little bit so I got more room. Yeah, because remember, when I'm taking the derivative of an exponential function, it's going to be the exponential function. It's going to be this thing times the derivative of the power. So yeah, it'll be e to the power 4 x squared plus 7x plus 5 times whatever we came up with, 2x plus 7, natural log of 4, 4 to the power x squared plus 7x plus 5. All that funkiness right there. No? Yes, sorry. Pretty rough, right? That's why you're leaving it as natural logs of 4, right? You're just leaving it like that. It's just like, think about it this way. Like if you had the square root of 17, you wouldn't simplify it, right? Because it's not going to be a nice, pretty number. So you would leave it as a square root of 17. So if you see something like natural log of 4, you guys, you just leave it as it is, okay? Yeah, because it's going to be, they're irrational numbers, right? So again, think about it this way. If you had the square root of 17, you wouldn't actually put 4 point a whole bunch of other nonsense, right? You would leave it as it is.
No, okay. Believe that. This is kind of the derivative before. Not the
Okay.
it's the limit of the portion of the portion logarithm, natural logarithm of 2, the alpha. So here's what we
Okay, so guys, let's take a look at the next one I got here. It says, find dy dx for y equals e to the x to the third times the square root of 2 minus x to the fourth. Okay, so let's see what we can figure out here. First thing I'm going to do is we're trying to find the derivative. So why don't we go ahead and use the quotient rule. So again, think about here as the bottom and think about there as the top, okay? So when we're going to find y prime, the formula for the derivative of a quotient, y'all, says we're going to take the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom one squared, okay? So look, we're going to say the bottom function. Well, the bottom function is 2x to the 2 minus x to the fourth, the square root of that, times the derivative of the top. Okay, so we're going to go slow. When we take the derivative of the top, it's going to be ex to the third, and then we have to take the derivative of the exponent. What's the derivative of x to the third? There you go. Perfect. Minus the top function. So the top function is that ex to the third, right? Now, we got to take the derivative of the bottom. Okay, so let me show you how we're going to do this part, y'all. Y'all agreed that 2 minus x to the fourth, the square root of that, could I write it like this? The bottom, because the square root is the same thing as the power of 1/2. So if I'm trying to take the derivative of this guy, don't I bring the 1/2 to the front? 2, oops, 2 minus x to the fourth. We got to subtract 1 from here. So what's 1/2 minus 1? Negative 1/2. And then we still got to take the derivative of what's inside there. So the derivative of what's inside there. So what's the derivative of 2 minus x to the fourth? A minus 4 what? You got it. Take it away. Good. Very good. Okay. Look, y'all. I'm going to put that right here, and I'm just going to do a little bit of cleaning with it. I'm going to write a fraction because I have a fraction right here. I already know I have a 2 on the bottom. Okay. Next thing I'm going to ask you, see how my power is a negative 1/2? If it's a negative 1/2, doesn't that really mean it's the square root of 2 minus x to the fourth, but the square root is downstairs because the exponent is negative, right? So if it's this way, if it's 1/2, we know it's square root. But if it's negative, it means that the square root is downstairs, right? Jennifer, am I doing okay? Did I do too many steps in one there? Okay. So look, are y'all okay with the is coming down to the bottom? Because the 2 is already on the bottom part of my fraction to begin with. Right? We're good with that? Okay. This piece right here, you guys, I can think of that as 1 over the square root of 2x minus 4. Why square root? Because it's power 1/2. Why does it go to the bottom? Because it's negative. That's why I put it down here. On the top, I still have that negative 4x to the third. Okay. Now, all of this, you guys, is over the bottom part being squared. If we were to take the bottom part of our function right there, and we were to square it, would y'all agree it would just be 2 minus x to the fourth? Because when you square the square root, they go away. There's our derivative. Ugly, isn't it? But there it is. Okay. I don't necessarily know if I would try to simplify it anymore. I mean, we've actually taken the derivative already. If we were to simplify it, what we're doing at that point, you guys, is just some algebra. Yeah, the derivative of ex to the third is ex to the third times 3x squared. It's always the same function times the derivative of whatever the exponent is. Right here? There you go. So a little messy, but that's what it is. Okay, we got another one here. Let's see if we can't figure this thing out. Again, y'all, we're going to use the same principles we were using before. I'm going to call this one the bottom function. I'm going to call that one the top. So when I'm taking the derivative of a fraction, it's always the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom function squared, right? Okay, so we're going to go super slow here. Let's see. The bottom function is 9e to the 4x times the derivative of the top. So what's the derivative of sine 5x? Cosine 5x, one more piece. Not times sine, but times one more piece of the derivative of the angle, 5. Good. Good part. Okay, so look, we just did the bottom times the derivative of the top. Here was the bottom function, there was the derivative of the top. Minus all of this, minus the top function, sine of 5x, times the derivative of the bottom. So look, y'all, the derivative of 9e to the 4x is going to be 9e to the 4x times the derivative of whatever the exponent is. What's the derivative of 4x? There you go. Okay, all over the bottom function being squared. So look, we're going to have 9e to the 4x all being squared. The only thing I'm going to do here, you guys, 9e to the 4, actually, let me put this. Since we're multiplying here, can't we take 9 times 5 and give us 45? Right, because that top part is this piece right here, y'all. All these folks are being multiplied together. So I'm just multiplying my 9 and my 5 to get 45 e to the 4x. Cosine of a 5x minus, look, let's do the same thing here. What's 9 times 4? 36 e to the 4x times the sine of 5x all over. Okay, we're squaring the bottom part, you guys. So remember what it means to square 9e to the 4x. It means take 9e to the 4x and multiply it by another 9e to the 4x. So 9 times 9 is? Okay, next step. What about e to the 4x times another e to the 4x? Anybody know what it would be? 8x. Whoa, why 8x? Because when you multiply your numbers with exponents, you add the exponents, don't you? Like if I asked you, what is x squared times x to the third, you would tell me the answer is x to the fifth, right? Same thing here. If I'm multiplying two numbers with the same base, all we got to do is add the powers together, okay? Guys, about the only thing I would do at this step, and the only reason I'm doing this is because I can see it. What can we divide all those numbers by? Okay. So 9 goes into 45, 5 e to the 4x cosine of the 5x minus 4 e to the 4x sine of 5x all over 9 e to the 8x. Well, the 9's on the bottom, right? Because it's still, you know what I mean? We divided all these numbers here by 9, right? Didn't we take all these here and divide them each by 9? So 9 went into 5, 45, 36, 4, 9 went to 81, 9. Right? That's all we really did, just dividing them all by 9, right? Just because we're just simplifying it, right? We're saying, oh, look, we can get rid of a 9. Let's do that. All right, so it looks like we got one last problem to do here, you guys. Again, we'll do it in pieces. We'll go one piece at a time. Let's call this guy the bottom. Let's call that one the top. And we take the derivative. Remember, it's the bottom times the root of the top minus the top times the root of the bottom all over the bottom function squared, right? Okay. So remember, we're finding y prime or dy dx, right? Okay, the bottom function, everybody agree, is 6 e to the 4x? Okay, times the derivative of the top. Okay, so remember, when we take the derivative of a natural log, it's going to be 1 over 2x plus 5 times the derivative of whatever that piece is. So what's the derivative of 2x plus 5? Good. Okay. Minus the top function. Well, the top function is the natural log of 2x plus 5 times the derivative of the bottom. So the derivative of the bottom, y'all, is going to stay 6 e to the 4x times, now I got to do the derivative of my exponent. What's the derivative of 4x? Good. All over the bottom function being squared. Anybody know what the bottom function squared would be? E to the 8x, right? Okay. So let's take a look-see here. If there's anything we can do. So if I put these two together, y'all agree that's a 12 e to the 4x and then a 1 over 2x plus 5 minus, isn't this one here going to give me a 24 e to the 4x and a natural log of 2x plus 5? Excuse me. Pardon. All over a 36 e to the 8x. All right, is there anything we can get rid of like we did earlier? 12, right? Yeah, we can get rid of these guys by dividing them all by 12. So wouldn't that just be e to the 4x and then 1 over 2x plus 5 minus 2 e to the 4x times the natural log of 2x plus 5 all over, we're dividing by 12, we said, right? 3 e to the 8x. So guys, I'm going to show you one extra step. Can we take this guy out? can we take that e to the x out, e to the 4x on both of them? Isn't it a factor of this piece, and isn't it a factor of that piece? So think about it this way, right? If I were to multiply it there, I would end up with this, and if I were to multiply it there, I would end up with that, right? Okay. Let me show you one more step. Isn't e to the 8x the same thing as e to the 4x times another e to the 4x? Because didn't we say that 8x, the way we got 8x is by adding the exponents together? You see what I'm saying? One last thing is going to factor. What do you think is going to factor out or cancel out? The e to the 4x, right? So look, I'm doing this. Now, I'm not saying that what we had here in the red isn't acceptable. I'm not saying that it's not acceptable. I'm saying that if it isn't, then there is one more way that we can simplify by getting rid of that e to the 4x. And if we do that, we're going to end up with a 1 over 2x plus 5 minus 2 natural log of 2x plus 5 all over 3 e to the 4x, right? Because remember, I had an 8x here, and isn't 8x this e to the 8x really the same thing as e to the 4x times another e to the 4x, because I'm really adding my exponents together? So this is just a more simplified version, okay? Again, y'all, I'm not saying that the red one is not correct. It is correct. It's just we could simplify it a little bit more. Just like we said, oh, look, we can divide all those numbers by 12. We can really get an e to the 4x out, okay? Now, before I go on, I want to scroll back to the problem that we did earlier over here. And if I take a quick look here, you guys, couldn't we do the same thing with our e to the 4x in this problem too? In this problem right here, the problem we did right before this one, couldn't we have said, look, if we factor out an e to the 4x on the top, I'm left with a 5 cosine of a 5x minus a 4 times the sine of a 5x, and I can think about that as a 9 e to the 4x times another e to the 4x, and then we can drop one of those e to the 4x's out, right? We can say, let's get rid of this guy and let's get rid of that guy, right? Again, I'm not saying what we had in the red isn't correct. It is correct. It's just this one is more simplified. Okay. Cosine minus sine is not a thing, right? It's got to be, they got to be squares. But why would you square both? You know what I mean? If you're going to square something, you're in essence you're squaring both sides, aren't you? And remember what we're looking for. We're looking for the derivative. We haven't ever talked about what's y prime squared. You know what I mean? So that's why you don't got to do anything there. Okay, so guys, before we go on, because we are officially done here, but before we go on, just to give you all a heads up, remember the quiz for chapter 3 is open. 10 questions, okay? And I just want to go through some of that stuff real quick. So let me pull up my thing here. Yes, so let me tell you what we got to do. So let me go to the student preview. Go like this. Okay, so let's see, what's due today? Whatever we did a week ago. So we're in week what? We're in week 6. So what did we do last week? 3.6 and 7. So 3.7 is due by tonight, right? 3.6 was due, I don't know why I said, oh yeah, Monday, it was due Monday, right? So this one is due by tonight. So today, you guys, so homework for 3.8 is due on Monday. Homework for 3.9, which we did today, is due next Wednesday. And so is the quiz, right? So the quiz, 10 questions over the kind of stuff we did. So let's see. Remember, you guys, the review is open. So just to give you a heads up, on Monday, I am going to teach you something new. It won't be on the test, but I wanted you guys to have enough time to go through the review. And I thought if we would review Monday, it may not be enough time. So that's why, and so we're not going to review till Wednesday. I got to do something on Monday, okay? So Monday, I am going to teach you something new. Won't be on this test, right? And I'm going to make the homework for what we do Monday, guys. I'm going to make it due after spring break, okay? Just because I want you to really focus on the review and finishing up your homework for chapter 3 and your quiz and all that kind of good stuff, okay? So again, next Wednesday, you guys, all we're going to do that day is review. So the objective for next Wednesday is to come in and say, out of those 40 questions, which ones do you need help with? And let's go through as many as we can in the 2.5 hours or 2 hours and 20 minutes, whatever it is that we have here, okay? That's going to be the objective for next Wednesday. So again, work on as much of it as you can. The ones you don't know how to do, just mark them or whatever, and then that day, okay, what things do you know how to do? Like, oh, I'm good with the first 7, I got stuck on 8. Okay, let's do 8. I'm stuck on 13. Okay, let's do 13. Let's keep working. Let's do as many of them as we can. So that's what we're going to do on next Wednesday. Yes, ma'am.
We can't just like work on the review on Monday and we're doing the next chapter.
But then what are we going to do Wednesday?
The test.
No, the test is not on Wednesday, right? The test is going to be the test is going to open up a week from today, and I'm going to give you a week to get it done. You have a whole week to do that test. When do you do the test, Jennifer? You decide.
You can't stop me there.
You can't stop in the middle, right? You can't stop in the middle, just like you can't stop your quiz in the middle, right? You can't. But you have a whole week to get it done. So the test is going to officially open up on Wednesday at 2:50, and it'll be due the following Wednesday by 12:30, which is the week we leave before spring break. Okay, that Monday before spring break, we're not going to meet. That's me giving you the day to take the test. So if you're like, my schedule's really, really busy, I don't have time outside of class, take it on Monday. You just don't have to come here. You understand my point? So it's basically doing it at home. Okay.
It's so hard to.
Well, remember you get 2 shots, right? So hopefully, hopefully,
Ow!
hopefully that doesn't happen, right? Okay, so guys, before you all leave, I know Matias, you had a question yesterday on that problem that you had sent. Do you want me to go over that one? So guys, if y'all want to hang out and do the problem that Matias asked, you're more than welcome to. If you don't need it, you're free to go.
I'm eating my lunch.
Eat your lunch. But Matias, do you know which problem it was? If you remember, great. If you don't worry about it. I want to make sure that I'm getting what you needed. You know what I mean? Ask me. Let me stop recording real quick.